And so, I hope you guys are doing good. Good morning, Jade. I hope you guys are doing all right. The To anyone here who's not getting up at 8 o'clock in the morning to watch a video, it's all good. It's all good. I know you guys are busy there today with your case studies. They're due there today at the midnight, and yeah, have a look at the. I put little one slide PowerPoint there to help you guys out with scatter plots. They're pretty easy, and you have a look at where the X and Y axis is, and I tell you all that, and yeah, have some fun with that. There was also what else was there? The quizzes, the assignments, the tests. They're, as far as I can see, they're 99% marked. There might be one or two cases outstanding that I'm aware of, and they are aware of. Morning, Elena. It's only the five of us. So, generally the marks were great. I'm not that difficult of a marker. There were a couple of systematic. Yes. Good morning, Elena. Good. There were a couple of systematic errors that I saw. When you're making your well, actually, you know what? I'm just gonna hold off on that. The PowerPoints there are two. They're not bad there today, but I put some things in there to remind me there to talk to you guys about future quizzes and these kinds of things there. So if there's any emergencies that need addressing as of right now, let me know. Other than that, let's just get on with this, and we'll talk about the quiz and the assignment and little things there that people can do to boost their mark. But other than that, generally class average is off the charts, so that's where I like it to be anyway. Just give me 2 seconds here, and I'm going to dig up there we go. There's week 7. So there, this week, you guys have all the questions. You guys have everything there that you guys need. And what else we got here? Case studies due there today. Next week we have quiz 2. And then the following week there is test 2. And yeah, I don't think this stuff is that bad, and I hope it's not that bad. And if it is that bad, please let me know. But other than that, let's go. Perfect. So today we're going to be talking about 2.3 and 2.4 measures of central tendency there for group data, skewness, and interpreting measures of central tendency. And if you go back there the past couple weeks, I've kind of alluded to this stuff right here. So actually, this just might even seem like a little bit of a review, even though we're actually covering it there for the first time. So, in a lot of circumstances here, it is practically infeasible, maybe even impossible, to access raw data, okay, in order to determine exact values. Now, what we're talking about here, like somebody funds a study is done, a survey is conducted, money's been spent, these kinds of things, and then maybe the results weren't what the people wanted, but whatever. That information is now recorded for the antiquities of time, and if allowed, if it's on the public record or somebody could pay to access it, this scientific knowledge is still available. And so somebody, in theory, which happens all the time actually, somebody will take someone else's work and remodel it, and turn it into something different. These kinds of things. So, like example here, large studies performed by a third party, historically government records, our surveys, maybe from 50 years ago or 100 years ago, where these people are long gone, but the science still holds true. And you can take this information, and maybe you don't have access to all of the individual data, but as you'll see here, we can still work on this stuff. So in these situations here, the value of the measures of central tendency must be estimated, okay, using summarized values of group data, okay? You have a look here. We use this one here. For this example here, we've got length of babies born in centimeters. Okay, 45, 46, 47, 48, all these in centimeters, right? And here we have your frequency distribution. So one baby in this particular study was 44 centimeters long. 3 babies were 45, and you'll see there, okay? The calculation of mean, median, and mode for group data is different from that used of ungrouped. Okay, we've covered ungrouped data there. All right, pretty easy peasy. But trying to find the mean of a group of groups, if that makes any sense. And you see, like group data, we don't really know exactly, other than, like you look at this one right here. Here I've got 13 babies were 48 centimeters in length. All right, and were they all 48.000000000000000 centimeters long? No. Okay, they were 48.273, 48.795, but we don't have exactly how long the babies were. Other than the fact that they were just put into a category, and in this one here, I got 13 babies that fell into the category of 48 centimeters long. Well, they were 48 point something. I don't have access to that, but we can still utilize this data, okay? And instead of, and basically what we're trying to do here is find the mean of a group of groups. And honestly, it's not bad. None of this stuff here is that bad there today. However, in some cases, the data is displayed in a frequency table with unique class values. The raw data can be reconstructed from the frequency table. So if I give you this right here, you guys should be able to bang out some information here. We'll show you how to do it. So consider the following example here of the birth lengths of 100 newborn babes. And you see here, since the exact values are known, the raw data can be reconstructed, okay, by listing out the length of each baby. So here we've got them all here. And y'all there remember the weighted mean. Same thing here. So in this particular situation here, you're going to multiply 44 times 1 plus 45 times 3 plus 46 times 6. And we'll show you this right here. You guys remember this formula right there? Okay. And 44 times 1 plus 3 times 45 plus 6 times 46. And you'll see here, right? You're just multiplying these two together and then adding and then multiplying these guys and then adding that to these guys here and dividing by 100. Why? Because there's 100 babies in the study. Okay. And here we've got a mean birth length there of 49.51. Okay. Not too bad. I hope you guys are still there. Yeah, I hope you got, it's early in the morning here, and I know you guys got a lot of things to do there today. You're at the apex of the semester. It's not going to get any less busy than it is now. Now is the time there to put the foot down to the pedal and keep it on going, all right? Let's say you wanted to find the mean of this data right here. Well, in order to find the mean is the middle point within the data, right? You got 100 babies ranked from shortest in length to longest in length, right? And if we've got 100 babies, well, the middle point is going to be, and you see the location of the median. You remember that formula there? Okay. And we have 100 plus 1 divided by 2 is 101. So the actual point that we're looking for is 50.5. Okay. Which doesn't exist because our points are points, right? We don't have half a point. So then we go to the 50th and the 51st data point. Okie dokie. And you'll see there that, and you see cumulative frequency. And this is one of the things there that I wanted to talk about. A number of people there didn't get this or didn't perform this correctly. And I just wanted to show you there that we're going to be walking over the same carpet again there for test 2, because statistics there, you've got your bag of tools, right? So there's going to be frequency tables and there's going to be cumulative frequency tables on test 2. All right. So like just the whole idea, this is a normal frequency distribution right here, right? But then your cumulative frequency, this is for your ogive, okay? You know, the ogive there that goes up like this, okay? It's an accumulation. You're kind of gathering all the stones as you go along. And you'll see here I have 1 baby, 44 centimeters, 3 babies at 45, 6 babies at 46, 9 babies at 47. Well, we want to kind of gather the stones as we go, and we call this a cumulative frequency. Okay, so here I've got 1 because there's only 1. But 1 plus 3 is 4. And then 4 plus 6 is 10. And then 10 plus 9 is 19. You see how, and this number here will always be your total. If you have 50 babies or 100 babies or whatever it is, right? Okay, so a couple of people there, they made mistakes on that. And please get a hold of me if that doesn't make any sense, because you will see that again. Okay, you'll have to be able to make a cumulative frequency table or a column there. Okay, now, and going back to here, we're looking for our 50th 0.5 point, which is the 50th and 51st data point. So you go on. So here is my 50th data point is right here. It's in the 49 centimeter category. And the 51st is in the 50 centimeter category. Okay, no worries. So the median there, you basically have to find the mean of the median. That's how we do the median. And the 50th and 51st point represent 49 centimeters and 50 centimeters. Add them up, divide by 2. You're going to do a little mean here. And you find there that the median birth length is 49.5 centimeters. Okay. What do we got here? The mode is just the most common, right? So you just go through, which one's my most common here? I have 1, 3, 6, 9, 13, 18, 20. Whoa, that's most babies, or the highest number of babies per category there that were 50 centimeters. So that is now your mode birth length. C'est bon? Not too bad. This is another area where people tended to make some mistakes. Okay. When you're doing these class intervals, okay, and it's, continuous data, right, decimal points, the baby was 48.127 centimeters long, right? It's continuous data. Every single number under the rainbow has to be covered. And the key to making these is under. This is this is kind of similar to what I was looking for there on the was it the quiz, the test, one of them anyway, where I asked you to make your own class intervals here, and some people had like 40 to under 48. And 48 to under, they had different groupings, but I didn't care. That was fine. As long as your groupings are exactly the same length. All right, so 40 to under 50, 50 to under 60. You can see that they're 10, 10, 10, 10, 10 apart. All right, I don't care if they're 8, 8, 8, 8 apart or 7, 7, 7, but they've got to be the same. And they've got to have that word under in there, because 40 to under 50 means every number under 50. So 49.99999999999. You've got to have that word under in there or it doesn't, okay, it won't work. So 40 to under 50. So 50 is not included in this. 50 is in here. And then every number under 60. 60 is in this group. To every number under 70. Gotta have that in there, okay? Because you'll see this again. All right, we're just building on skills, and this is new to most people, so it's all good. Marks are pretty decent, which is where I like them. So that's where we're going here. So in most cases, their group data is organized into a frequency table, class intervals, frequency with no way of knowing the exact values of the data. Okay. Therefore, the best we can do is use the midpoints of the class interval. So you see how this is different than, you remember these groups here? Okay, the ones we just did, mean, median, mode. Okay. Now we have these guys here to deal with. Are they any more is it any more difficult? Not really. We'll just show you guys the steps. So here we have this little table here, little frequency distribution. So for whatever we're talking about here, I'll show you there next. But you see, we've got 4 students here. Obviously, here we're talking about an exam. Who have 4 students got between 40 and under 50. 5 students got 50 to under 60. The majority of the students, 18 students, were in the 60s. Okay, so have a look here. The distribution of marks out of 100. Okay. Following statistics exam for a sample of 50 students. Okay, so your total is 50. Okay, and the tests were out of 100. So here's your little frequency distribution. Okay, and so to calculate the mean, all right, again we're using the weighted mean. Okay, so the mean there, we use a weighted mean with. But the only difference is, you'll see here that, what are we going to multiply again? You're going to be 4 times the midpoint plus 5 times the midpoint, which is 55. 18 times the midpoint, which is 65, plus 10 times, and you'll see here, I've got a little formula down here. So to calculate the mean when you have these intervals, okay, you multiply the frequency times the midpoint. Okay, and I've got this. This is really confusing. I've left this on like you can with the animation here. So you see, this is what we got here. We've got the class intervals, exactly what we just had. We've got our frequency. Okay, n is equal to 50. Midpoints. You know, and you'll see here class midpoints. What I'm looking for is the mids of all these guys right in here. So 45, 55, 65, 75, 85, 95. Okay, they are here. Now, weighted midpoint is you multiply this one times this one. Here you get $1.80. 5 times 55, you get 275. 18 times 65, you get 1,170, and so on. And then you add all these guys up. And so we'll show you a bit of the animation if this might confuse you more, but okay. So there we find the midpoint, and you plot that number in there. Okay. And then you multiply these guys, because your formula, okay, for finding there the midpoint, okay, 180. Okay, so that's what we're dealing with there. So anyway, you add all these guys up, you get this number here, divide by 50. Okay, sorry if you guys can't see that. I'll just come right out of there. So you see, that's all we're doing there. So you're using the weighted mean to find the mean here. And the only trick to this one here, and you see, that's what statistics is. Everything kind of is pretty straightforward, but for basically every question, there's a trick that you got to know. And the trick for these ones here, you're going to use the weighted mean. and you're gonna, it's the frequency times the midpoint of the class interval. That's all it is. To find the medium. Sorry, did I just say medium? Median. Same example, okay? So we're using the same example here. We just did the mean. Let's do the median. Is it any real? It's not really different than what we've just done there before. Write this down somewhere. Whenever you're doing the median, you will need a cumulative frequency table. Cumulative. Remember the ogive? You're gathering all your apples as you go. Last number will be your total number. Okay? And you'll have to use this formula there. So what we do is, it's your same information. Remember, you just calculated the mean, right? And great question. I'll give you a set of data. Shoot me the mean, median, and the mode. Oh, did I just give that away? Oh my goodness, I just shouldn't have said that. And you see, same data here. You got your groups, you got your frequency. There's your midpoints, right? You already calculated your midpoints. There's your cumulative frequency. So 4 plus 5 is 9. 9 plus 18 is 27. 27 and 10, 37. So there's your gathering all your apples. That number there will equal 50. That's your total. So you have 50 data points. So since you have 50 data points, location of the mean is n plus 1 divided by 2. 50 plus 1, okay. All right, divided by 2. So we're looking for the 25th and a half data point. Doesn't exist. Okay. So we're actually looking for 25 and 26 data point in order, right? So where's the 25th? Well, that will be in this category. Okay. 25th data point is in here, and the 26th data point is in here. We want the 25th and 26th, right? Because of this 25. Okay. So what we're looking for there is the median class. Okay. So the median class is going to be in this group right here, 60 to 70. Okay. And then we just use the midpoint of the class there, and the median or the middle point value of this class here, this class interval is 65. So therefore your median exam mark is 65. Okay. Not too bad. It's kind of running over the same carpet again and again and again. And but yeah, it shouldn't be too bad. If there's any issues that y'all know, just give me a shout and we'll get a WebEx done. Modal class, you just find the most common, right? That's all this is. So what do we got here? Most common is 18. So 60 to 70 is your group. And that is how you do the modal class. Okay, you don't go to the midpoint there for the actually, where do I, with group data, it is more common to refer to this as the modal class than the mode. So if you're doing ungrouped data there, you can find the mode easy peasy, but when you're dealing with class intervals here, you're just finding the modal class. So in this case here, your answer would be the modal class for this data here. The most common exam mark was in the 60 to 70, 60 to under 70 range. That is your modal class. It's good. And there's your answer right there. Therefore, the modal class is 60 to 70. Perfect. And these are just review questions here. Okay. And the following table shows the number of hours per day. A sample of 60 people spend watching Netflix. Compute the mean, median, mode. Okay, so there to find your mean. Okay, there's your weighted mean. 0 times 0 plus 1 times 1 plus 8 times 2. You know what I mean? So there our median hours there for watching Netflix per day is 3.98 hours, or basically 4 hours. Okay. For the median, you just use your formula right there, find your middle point, Okay, you do your cumulative frequency, right? Median, you will need the cumulative frequency. There you go. You find that one. There's your mode. And we're done with that one there. Okay, don't go anywhere. I'm just going to stop sharing for 2 shakes of a lamb's tail. Hey, very good. We've got 6 people. And it's okay. I understand you guys are probably pulling your hair out right about now. And you guys are doing great. Just keep on it. And get those case studies in. I think they're worth 9 marks or 9%. And yeah, I hope have a look at the what am I talking about here? Have a look at the stuff I've given you there to assist you on scatter plots. There's a little one slide PowerPoint there to help you guys out on PowerPoints on scatter plots there. So, but if you guys have any issues, let me know. All right, there's still time, and if there are family issues or health issues on the go here, please keep me in the loop. All right, and we'll get things done. Where are we here? We are now on to 2.4. We just did 2.3, okay, for group data. This one here, you'll see it's not very big. It's like 19. Like, we'll be done this in there in a couple of minutes, okay? But this will actually kind of seem like review because I've actually thrown this in a PowerPoint or 2 ago, okay? Here we're trying to talk about skewness, and without making a graph, we'll be able to make a graph. Dude, that was horrible. All right, I'm going to give you some data, and organizing this data without making a graph, you will be able to know what this graph looks like, and we'll show you these right here. Let's go. The measures of central tendency, the mean, median, mode, they give us a variety of ways of interpreting where the center of the data is. Now, you'll remember that, we talked about sample sizes of data, and but where we're at there today now, we're starting to progress into kind of the larger format, the larger forum of statistics, where we're looking at all of the data. And position of the data is very important. Like you remember the word bimodal. Like if you have a graph that peaks here and then has 2 peaks. Well, that's awesome, because then that's giving you 2 bits of information that people, because generally we're talking about people, people are congregating to 2 different areas. There's a bump here and a bump here on your graph, right? Bimodal. Okay? Why is that? Why are ideas or attributes congregating around a central theme? Now, maybe your graph is unimodal, only has 1. Well, then that means that everybody is congregating to this idea. Why? And this is where stats gets interesting, is why. All right? Neighborhood demographics, age, these kinds of things, right? And this is where it gets interesting. Just a little recap here. The mean is the balancing point mathematically of the data. So your mean is the mathematical middle balance. Okay? If I got 100 points on this side, if I got if your math adds up to 100 on this side, it better be 100 on this side. We'll show you what I'm talking about here. The median is the middle value or number, right? Cumulative frequency, right? You're gathering all your apples as you go. The very middle, you're putting them into sequence from lowest to highest, kind of like a stem and leaf, all right? And the median is the middle value or number in the data distribution with an equal number of data values above and below. So it's just the sequential middle. This one here is the mathematical middle. And the mode represents the most common. All right. A little bit of review. So you'll see here, symmetry, stats loves symmetry, because if symmetry occurs, then that means there that you basically have true equivalence, which is what we want, and something called zero skewness. Okay, there's equal ski hill on either side. Okay, so if the data has one mode, and you see here in a graph where there is zero skewness, you'll see here that your mean equals your median, which also equals your mode. Okay, kind of makes sense, right? Because if you've got a perfectly symmetrical graph and results here, well, this has to be your mode, your median, and your mean all in one right here. Here we have the example there of bimodal. Okay, and if the data is bimodal, the two modes will be roughly equally spaced on either side. Okay, so here's your mode. Here's your mode. And you'll see there your median and your mean are still in the middle. Okay, and you will have to carry this knowledge with you. In a bimodal system, where's the mean, where's the mode in comparison, where's the mean, where's the median in comparison to the mode? Know this. This one here, in a zero skewness, okay, unimodal. Know this. What do we got here? Here we've got what's called positive skew. Okay? And now positive, I don't know how y'all want to remember this, but you know what I mean? Here's your graph, right? This is your 0, right? And if it's positively skewed, that means that this is going out towards the positive end. All right? So that's what it means. A positively skewed graph means that it's got the skew on the right side. It's going to the positive side. And oppositely, a negatively skewed graph will be, the skew will be to the negative side. Okay, I'll show you. I have another one of those. Okay, but what I want you guys to see here, in a positively skewed graph, okay, your mean is greater than your median, and you'll see here. Here's your skew, and you'll see here what that does to the mean. And why does the mean, it gets pulled off of its center here? Because there are outliers. Remember those outliers, right? And the outliers will affect the mean because it's the mathematical middle. And if you've got these big numbers over here, well, the mean is going to get dragged over that way. And you'll see here, in a positively skewed graph, your mean will be bigger than your median. And your median be bigger than, there's your mode right there. So please know, in a positively skewed graph, it skews to the right, and mean, median, mode will be like this. I'll show you why. In a negatively skewed graph, as I said there, this skew goes towards the negative side, the left side. And in this particular case here, your mean is less than your median, and your median is less than your mode. Okay? That's how these guys go. And I want you guys to be able to recall this. Why? Because we're going to give you, and you'll see here at the end, is it here? Yeah. What I'm going to ask you to do is I'm going to ask you to calculate the mean, median, mode for a given set of data, and then, without making a graph, just looking at the numbers, you're going to tell me, is it positively skewed, or is it negatively skewed, or is it not skewed at all? That's it. So, going on back here, where did I go? Right here, negatively skewed. Whew, man, it's already humid. Good one. So, for asymmetrical, so non-symmetrical data distributions, the mean, median, mode will differ from each other. Okay, so if the data is skewed, you'll see there your mean is not equal to your median, which is not equal to your mode. Same for this banana. All right, but you'll see here They're all the same there. That's unimodal. Here's bimodal. Just different examples there for you guys to recall. Okay. When the data is skewed significantly, the median tends to be a better measure of tendency. Okay, I'll read that again. When the data is skewed significantly, the median tends to be the best measure of central tendency. Why? Because if you got skewness, you've got those outliers. And depending upon the skew, you could have a lot of outliers, right? There could be something significant way out there on the graph. It's still science, right? So in skewness there, the median tends to be the best because the mean is the mathematical mean, and because of those outliers there, it will drag the mean to whatever side of the skew it is. Okay? Good. So, the table below summarizes the results of a statistics exam given to a class of 60 students. So here, there are my groups. Have a look at those groups. This is what I'm going to be looking for on test 2. Okay? I want better graphs there this time. All right? So there's your frequency distribution. And here we're looking for estimate the mean and median and determine the modal classes of the group data. Perfect. Use the information from question 1 to determine skewness and shape of the distribution. Not bad at all. Look at this. We're almost done. So, estimate first the mean, then the median, and determine the modal classes of the groups. So, student marks. And because we're dealing with groups here, okay, we're going to find median mode. You better just get the midpoint right off the bat. Bang. Midpoint. 20 to under 30, 25, 35, 45, 55, 65, 75, 85, 95. Okay, there's the frequency there that was given to you, okay, from before. Because you got to calculate the median, you must give me a cumulative frequency, carrying your apples as you go, okay? And that number there should always equal your N total, which is 60, okay? So, and using the formula for weighted mean, okay, 2 different ways to write it here. This is basically the sum of the frequency times the midpoint there. And if you, this is from the previous PowerPoint that we just did 5 minutes ago. Whatever formula you like, it's all the same banana. Okay, so you have 3 times 25 plus 5 times 35 plus 8 times 45. And please be careful when you're doing this in your calculator. You'll see there's a lot of things going on here. And I've seen it. I told you guys this before. I'll tell you guys again for sure. Don't let the calculator make the mistakes here. And you can see here that if you wanted to punch this whole thing into your calculator, you could. Bracket 3 times 25, bracket plus 5 times 35, bracket plus. And you see there's a lot of brackets. There's a lot of buttons being pushed. And eventually, this thing is so long that it's going to go off your calculator screen. So you're going to lose track of what you have and what you know what I mean? And then it's going to spit out a number. And you have no idea if that number is right or wrong. So a little bit of advice when you're doing a calculation like this, and you will, promise, break it down. So 3 times 25 is 75. Plus 5 times 35 is what, 175. Okay, 8 times 45 is 320, 360. Break these all down into real numbers and add them all up. Okay, and then that's how there's your mean there. Okay, all right. So your mean is 62. So what we're doing here to find the median, okay, cumulative frequency, you have 60 data points, that's given. How do you remember location of the mean is n plus 1 divided by 2? Well, you have 60 data points, 60 plus 1 gives you, so we're looking for 30.5. So really we're looking for data point number 30th and number 31st. Okay, so Where's 30? 30 and 31 is in this group right here. 60 to under 70. Okay, and you remember to calculate the midpoint of that, which is 65. Okay, so you remember there that our mean we calculated is 62. Our median is 65. And our modal class, well, you just go through which one is our modal class. Don't use this one for your modal class. Use the original frequency here, frequency table. And you'll see there, I got 12 and I got 13. So 70 to under 80, that's my modal. Okay? That's my modal class there. That's what we're looking for. But I would also notice that I have another group here that's pretty close. So in this particular case, I would probably call this a bimodal system. It doesn't have to be perfect, but you got a bump going on this side of your graph, and you got another bump going on over here. Even though this second bump isn't as high as the first, I got 12 and 13, they're still good to go. You've got congregation of same ideas around a certain point, and you've got one in the 70 to under 80 category, and you've also got another one there, 50 to under 60. So we would call this bimodal. Okay, and if you graphed it all out, this is what it looks like. All right, but you don't have to graph it out. So we got the mean as 62. We had the median as 65. All right, so here the median is more than the mean. Go back to these ones here, okay, where the median is more than the mean. Whoa, what's going on here? The median, so this looks to be negatively skewed. So I'm just trying to find this. And that's what we've happened here. Okay, the median is more than the mean. We've got a bimodal peak here. Okay, I think this one was 13, this one was 12. Okay, and this is what we're doing here. So to answer this question there, you found the mean, you found the median. It's bimodal. It is negatively skewed because the median is more than the mean. And again, that comes from these graphs here, which I've emphasized a couple of times, okay? Have those around on test day for sure, okay? So since there are essentially two modal classes, the distribution of this data will appear to be like camel hump, okay? With two mounds in around 55 and 75, okay? So there is a relationship there between the mean, median, and mode of given data set, okay, derived empirically. For example, calculated from observations. This is a cool little formula here that I will test you on. Is it difficult? No. There is this non-scientifically yet scientific relationship there between the mean, median, and mode, and someone has put it into a formulaic expression. And you'll see here. I'm just going to jump right to here. And somebody came up, the mean minus the mode is equal to 3 times the mean minus the median. Ugh. Let's try and clean that up a bit, shall we? This is what you're looking for right here. I call it the 1, 2, 3 formula, where 1 times the mode, so it's just mode, plus 2 times the mean is equal to 3 times the median. And to go into the relevance of what this all means, it's all good. Y'all can do that on your own. But this is the formula there. There's a little formula there that I'll test you on there for the next test. Okay, where the mode plus 2 mean is equal to 3 median. And I'll show you a question here. It's not bad at all. So have a look here. In a sample of patients seen in the ER of a hospital, the median height, according to the patient's driver's licenses, was 169 centimeters. And the most common height recorded was 165. So here I have the median height, 169. And I got the mode height was 165. Okay? Using the formula, the mode plus 2 times the mean is equal to 3 times the median, we can substitute in known values and solve for the mean. Because see, median, this is the mode. Which one are we missing? The mean. So plug and play. So, stupid mouse. There we go. Good. So, you plug in the numbers and away you go. Looking for the mean. So I got mode plus 2 mean is equal to 3 median. Okay. We have the mode 165. We do not have the mean. Leave it as that is equal to 3 times the median. Okay. Mathematically solve for the mean. And there we go. Mathematically there, the mean for this guy is 171. Any issues with that? It's just a little simple algebra. Plug what information I've given you and then get out an answer there that I'm requiring. Okay. Here's another example here. An example of patient scene. Yeah, same thing here. So you can even use this information there to determine the skewness. Now this is kind of these graphs up here that we were looking at. I kind of like these because they're visual, but y'all can have a look right here. This is a nice little graph that kind of summarizes those for skewness there. If it's skewed to the left, okay, it's a negative skew where the mean is less than the median. If you have a skew to the right, which is a positive skew, where the mean, okay, minus the median there is equal to 0. So have a look at these there, right there. And like this question, great little question, couple marks. Okay, you can determine whichever one I didn't give you. And then from this information there, looking at your mean, median, mode, you can actually, you can tell everything without even making the graph. Okay, so, and here are some review questions there. Y'all can have a look at those. And as well, the Q&A are all there. Okay. For this week, you guys have the questions. There's all the answers. You guys are all good to go. So that's what I've got there for today. How you guys doing? Any questions? Talk to me. That's what we're looking for there. You guys are doing great. Keep going. Yeah. I don't really see any major issues. Class average was pretty high. I'd actually like it to be higher. Okay, and I don't see a reason why not. We have our quiz 2 there next week, which will give you kind of an indicator of what's happening there for the test 2. And your case studies are due there today at midnight. Okay, so whatever you guys need, just keep on trucking and let me know, keep me posted. But other than that, enjoy your day. Any questions? Stick around. Other than that, we'll see you guys later. I'm going to stop recording.
And I just have a question about question 2 for the case study for the scatter plot.
All right. Let me... Yeah, okay. Let's go for it. I'll still record. Yeah. Go ahead.
So for what you were asking us to do, there's a bunch of spots that are like duplicates. You know what I mean? So like the X and Y would be the same.
Yeah, exactly. Like I know exactly what you're talking about. Your graph, I don't know, I forget how many data points we have in total for the case studies. 34? Yeah. And when you're putting your scatter plots on, I think that you only see, I'm going to throw a number out here. It's not actually the number because I don't know, but you're only going to see 26 data points on your graph. Why?
Okay, so that's okay. You don't
Hey, man. Hey. That's exactly awesome question. And yeah, on your graph there, you're only going to see like 24 data points or 27 data points because you'll have 2 data points on top of each other, right?
Okay, so don't put the duplicates, you're saying. Cool. Thank you.
Good question. Keep it up. Anything else? How are we doing? We good? Maybe some people... Hey.
I have a quick question.
What do you got?
In addition on number 2.
Sorry, Jesse. Sorry, man. You cut out there for a second.
So did you want us to label the...
Sorry, brother, I can't hear you, man. There's if you want to write it into the chat, I don't know how fast you can type, but I got a question about number 2. Try again, Jesse.
Can you hear me now?
Yeah.
On number 2, did you want us to put label the points?
No. Don't worry about that. For a little hint though, there for I forget if it's question 2. I think it's question 1 where you're making the histograms. Where you have your number of males or females going up the y-axis, and what will really kind of help is put those. Is it per day? I forget which one. No, that's for the scatter plots. But for number 1 there, group them into little groups of like 1 to 2, 3 to 4. You know what I mean? If you don't do it, it's okay. But it kind of helps if you kind of put them into groups. And but yeah, that's it. Good questions. Keep them coming. What else you got there for the case study?
Likewise on number 3 with the points. What did you want us to? Did you want one of them on the bottom and one of them on the x and one of them on the y-axis?
What do you mean?
For family acceptance and
what have we got here now? Yeah.
Interest. Yeah.
So hold on here. Let me do some digging here. I'm coming. So this is for question 3?
Yeah.
All right. Give me 2 shakes of a lamb's tail here. I'm just going to try and pull it up so that I can read it and provide you with a half-decent answer anyway. So, okay. So this is for number 3, right? And yeah. So what is number 3? So your scatter plot, for the, and here I will pull this up right here. So, sorry, I'm just kind of talking to myself right now, and you guys are, I'm just getting everything ready. There we go. So, for your scatter plot here, like whatever you've got, this is how it should look like there. You should have your per day, your numbers going up the side, your family acceptance there, okay, whatever the number is there. And I put this in here just to show you how the numbers came about, okay? But you wouldn't have 5 and 3 out there, okay? So yeah, you just have whatever it works out to be, 5 and over 3. That's a scatter plot. And this one here, it's quite amazing. You're going to see something, and this is the whole idea of this case study is kind of preposterous. You got to think about it, right? But I promise you, this is a scientifically sound experiment that's been replicated, and the repercussions, as silly as this, you know what I mean, the whole idea, the repercussions of this are outstanding. And big pharma, you know what I mean, companies there, maybe Warner Brothers, movies, all these different mega companies, they would be interested in data like this. You could even further break this data down into age groups, you know, and whether this is acceptable between, 6 to 10-year-olds or 10, you know what I mean? And this has huge demographic implications upon societal procedures and implementations and how we daily, you know what I mean? And I know it's silly, and but it is scientifically sound, and it's health. It's a real study. And this one here, you will see something dramatic. All right? And it's brilliant. It's silly, and hopefully it didn't, it's not too bad, but it's very interesting. It's very interesting. Maybe not your alley, but you know what? Y'all are in pre-health. This is health. And just because the body does something distasteful doesn't mean that it's not health. everything is health when it comes to, and everything needs to be studied, and everything has ramifications and repercussions upon society. Okay, and yeah, it's not really not up my alley, but it's a good study. And where you guys are headed, you guys are going to be nurses, vet techs, firefighters, ambulance, wherever you guys are going to go. You guys are going to see the body is awesome. But yeah, let's just leave it there. How are we doing? Questions? Talk to me. No?
Good morning.
Hello. Hi, Megan. How are you?
I'm doing okay. How are you?
Surviving.
I get that. Okay, so I have two questions. One about the histogram. If we didn't group them together,
It's all right.
are we gonna get
No.
marked
No.
off?
It's.
I know it's easier.
Yeah,
but
yeah.
I've already done the graph twice because first I did it the opposite way, and now I flipped it, and then I'm like, oh no, I seen your email this morning. I was like, now the group it.
Good.
Damn.
Hey, no, you don't have to, but you're going
Okay.
to you're going to get the same results. All right. And you remember with stats there. You know what I mean? Black can be white, orange can be up, and you know what I mean. It all depends on your perspective, right? And no, you'll be fine. You should be able to get the same data. What else you got? Question
Okay.
2.
Good. And then the scatter plot, I overheard, I think it was one of our fellow students about the multiple data points. I put all the data points in like a cluster.
Fine.
Should I?
Nah.
That's fine. Okay.
No, don't waste any more
All right.
trees. Don't do it. I'll know what you mean, and it should be all right. And yeah, don't worry about that. You'll be fine.
Okay, cool. I think that's all I have right now.
That's it. Oh, you're doing
Well-
great, man.
I'm trying to get from Toronto right now, and it's a little crazy out here.
You're driving.
I am. Don't worry. It's all in my car.
All right. Stop talking. Get driving. Bye. All right. Drive safe. If anyone has anything, come and see me, set up a time, email me, and but other than that, I think y'all are just doing great. Just keep kicking the can, and hopefully there, like I said, week 1, that this course here, I don't want it to be a problem. Yeah, you're going to have to bust it up and get some work done in my course to get out of here with a half decent mark, but hopefully there you guys have seen there that it's not as taxing, I hope, as the bio and the chem. Normally, when I teach bio 1032, exactly what y'all are doing right now, I think in and around this time, you guys should be at digestion, no? This is what, week 7? You guys should be in digestion or respiration somewhere in there. Urinary nervous coming up soon. And this case study kind of ties into the bio. And honestly, if I didn't give you a case study that wasn't related, if I gave you a case study that wasn't health related, you know what I mean? I don't think I'd be doing my job to the best that I can be. And so, yeah, normally this case study ties right into digestion in my bio 1032. So, yeah, hopefully there you guys can make the assimilation and understand that we're trying to do our best to cross bridges and not keep courses distinct. All right? Because this is pre-health. There is an objective here. It's biology and it's chemistry, okay, mixed together. That's what our bodies are, biochemistry, all governed by the laws of physics. And physics is just another fancy word for mathematics. So, other than that, I got nothing. So get out of here, enjoy your day, go for a walk in the rain. I might just do that right now, take the pooch there for a walk. But other than that, thank you guys very much. Stick around. I think Subin there, we're going to meet up right now. But other than that, if you guys got nothing, I got nothing. Okay, guys, have a good one. I'm going to stop recording, and away we go. Enjoy your day.